Hello, ladies and gentlemen, and welcome back to more of our open contest. We're going to be starting part C of the contest now with question C1, and then we'll do C2 in the next video, and so on. So these are the harder questions. They do require full explanation, so we'll be trying to write up and justify anything that we claim. And what have we got? A quadratic polynomial, f of x, equal to x squared plus px plus q, with p and q real numbers, is said to be a double-up polynomial if it has two real roots, one of which is twice the other. Okay, so if r is a root, then 2r is a root. So the only way you could have a double root is if r was 0. Then you'd have the same number twice. Alright, so C1a, what have we got? If a double-up polynomial f of x has p equal to negative 15, determine the value of q. Okay. So x squared minus 15x plus q is our f of x, and we want to know, well, what's going to be q? Okay. Well, we know that all these double-up polynomials are going to factor as x minus r, x minus 2r. This is what every double-up polynomial looks like, where r is one root and 2r is the other root. So what do we have? Well, if we expand this side out, we get x squared minus 3rx plus 2r squared. And if we compare these, let me say something like comparing coefficients. One of the nice things about polynomials is if they're equal for all values or even most values of x, then their coefficients have to be the same. So comparing coefficients, negative 15 is negative 3r, and so r is going to be 5. And then q is 2r squared. Well, we'll plug that 5 in. You'll get 2 times 5 squared, 2 times 25, or 50. So q is 50. And we would just make a note of that. Okay. I have a feeling that this factorization might be useful continuing on, because I suspect we're not just going to abandon the double-up polynomials after having them introduced. B. If f of x is a double-up polynomial with one of the roots equal to 4, determine all possible values of p plus q. Okay, same sort of thing. So, either 2, 4 are the roots, or 4, 8 are the roots. Alright? So we would you could, I guess, expand these two possible polynomials out. That would be fine, and then, or you could say, well, either r is 2 or r is 4 using our previous work over here, and then we've got formulas for what p is going to look like and what q is going to look like. Okay, but either way is fine. So x squared minus 12x plus 32. So p plus q either equals negative 6 plus 8 or negative 12 plus 32. So this is equal to either 2 or 20. And there we go. And we just properly indicate what our answers are for whoever's marking. Okay, so that finishes B. Now let's finish off the whole question with C part. Determine all double-up polynomials for which p plus q is equal to 9. Alright, well, all double-up polynomials are of the form x minus r, x minus 2r. That's the definition. Okay? That one root is doubled, and that becomes the other root. So this becomes x squared minus 3r x plus 2r squared, as was already pointed out. So p is negative 3r, q is 2r squared, so we want 9 to be equal to p plus q. So this is going to be negative 3r plus 2r squared, and this is just a nice little quadratic. Bring the 9 over to the other side. Because of the 2 there, I don't think this is going to be particularly nice to factor. It might be, but, well, I don't know. Let's try 2r and something and r and something. They need to multiply to negative 9, so I suppose we could do negative 3 and positive 3. That'll give me negative 9. And then 2 times negative 3 plus 1 times 3 will be negative 3. So, yeah. So, therefore, r is 3, or r is negative 3 halves. Now, we weren't asked for the roots. We were asked to determine all double-up polynomials. So, once we know what r is, p is negative 3r. So, that's negative 3 times 3, or negative 3 times negative 3 over 2. All right, using the r's that we just figured out. And q is 2r squared. So these will either be negative 9 or... Now, I could just say, well, I know p and q have to add up to 9, so the q here corresponds to 18. But what I'm going to do is I'm going to double-check my arithmetic by actually calculating the q's separately, and hopefully everything should add up to 9. This one here would be 9 over 2. So I should get 9 over 2 for my other q, and 18 as well. So 2r squared, so that would be 2 times 3 squared, which would be 18, or 2 times negative 3 over 2 squared, and that'll be 2 times 9 over 4, so 9 over 2. So the only possible double-up polynomials are x squared minus 9x plus 18, or x squared plus 9 over 2x plus 9 over 2. And there we go. We know we're only going to get 2 because we got a nice quadratic in terms of r over here, r being the root that isn't the doubled up root. And there we go. And so we could even figure out the first one's going to have roots of 3 and 6. And you could even double check those polynomials. And the second one's going to have roots of negative 3 halves and 3 halves. And you can, oops, I just realized I wrote another x down there while I was looking over the page. There's an x, that should be a 2. I don't think I would lose marks for a little typo like that, because all my work's already up above. But it's important to make sure everything's looking good. Okay, so that finishes off C1 from our 2015 paper, and we will take a look at C2 in the next video. Hopefully you can join me for that. Until then, take care and keep enjoying math.